Hi, everyone. My name is Aisha Creary, and I am a licensed professional counselor, supervisor here in the state of Texas and in the state of Missouri. I am a registered play therapist. I am a Santrade certified. I hold a Texas Educator Certificate in school counseling, special education, and EC through 6th grade generalist. I hold a National Certified Counselor Certificate. And we are back with another episode of Postgrad with Aisha. And today, or for this video, we are going to get into the mathematics of the NCE. So a lot of people are afraid to touch the math questions. And I always try to explain to people, create an image that's going to help you answer the question, one. And two, avoiding or guessing on those questions will make or break you. So I want to make sure that I at least show you how to best answer those questions. And thankfully for you guys, I used to be a math teacher and I love everything numbers. Although I am a counselor, I love numbers. So again, episode Postgrad with Aisha, and we're going to talk a little bit about descriptive statistics, which i.e. is equivalent to the mathematics-based research questions on the NCE in regard to reading data and statistics from an assessment or a group or a set of data that is provided to you on the assessment. So again, life is much easier when you try. Now, that doesn't mean get stuck on the question. That just means give it a try based on the information that I'm sharing with you. So we are specifically going to go over mean, median, mode, and range. You'll probably less likely see range, but you will probably see mean, median, and mode. But I'm going to go over all four. You're also going to probably see some bell curve related questions. And it may not be asked specifically from a bell curve diagram, but I'm going to show you how you can use the bell curve on the exam to answer any question in relation to standard deviation, state 9, T-score, Z-score, and percentage of your data based on the question that you're given. Then we're also going to look at skewed distribution, and then we're going to also look at information in regard to correlation, not necessarily the correlation coefficient, but we are going to talk about, the correlation between data on a given graph on a given graph. So let's jump into it. So the first thing that we're going to start with is going to be our bell curve. So you'll probably see me looking around all around, but I am going to screen record on my iPad. So that's why I'm looking down. So let's start again with the bell curve. So I'm going to show you two different bell curves. They're pretty much identical. The only difference is the information that is shown on one is not the same as the information shown on the other. Or I'm not going to say not the same, but there's going to be one graph that's going to be more in detail, and then there's going to be one that's less in detail, but we're going to get into that. So let's check out the bell curve. So we're going to start with information in regard to what is the bell curve? What does that actually mean in regard to how to interpret questions or reading questions that ask you questions that you can easily just draw the bell curve for to help you answer and solve the question. So the bell curve is described as the shape of data conforming to normal distribution. So what that means is if you think about test scores that you've, or just your undergraduate or graduate classes, and if your professor, let's say, lists all the data, it's typically put on probably like a bar graph, or it may show up on a bell curve. So what you will see is like on a scale of 0 to 100, let's say that's the test score scale range. Majority of your data, right? If you look at the bell curve that's displayed on the screen somewhere, I can't tell where it is. What you'll notice is majority of the data is going to be where that peak area is. And there's going to be some outliers to the left and some outliers to the right on the bell curve. So if we look at the bell curve that we have here, again, typically your data you're going to have a few outliers of people who actually failed or fell below the mean. And then you're going to also have a group of people that scored significantly well on data or scores, and they're going to be the outliers on the right side of the graph. The middle portion of the bar of the bell curve is going to be where majority of students may have scored on an exam, whether it's a passing score where majority of the population is, or whether it's a passing score or a failing score of majority of where your data falls. Now, this graph that you see is an ideal situation. Now, there are two different other types of bell curves, and we'll get into that when we talk about skewed distribution. But for the sake of this part that we're going to get into, this bell curve that you see, I want you to focus on Z-score, T-score, mean, and standard deviation. So what is the actual Z-score? So Z-score is defined as the mean of 0 with the standard deviation of 1 point. So Z, typically you'll see people using Z-score as interchangeable with just the mean standard deviation is what you'll typically see. Now, I'm not saying to use them interchangeably, but store the information in your brain how you need to. So your mean, in a perfect world, your mean, median, and mode will all be the same, which is how you will have a normal distribution of data where your bell curve is pretty much equivalent on the left half and on the right half. So in best case scenario, that's how it will show up. Mean, median, mode would typically fall where your mean is, or the middle of your bell curve. All right. Your standard deviation is 1, 2, or 3. Now, when we get into the Z-score, there is a lot of specific information that will show up there. So for your Z-score, your mean or your average is going to be 0. Yes, your standard deviation may be 1, 2, or 3, or -1, -2, or -3, but it is based off of the standard deviation that is going to be given to you on an exam. Now, there are ways to calculate the true standard deviation or the amount of distribution from one standard deviation to the next. But for the sake of your test, you're not going to need to know how to calculate the actual distance between the mean and the next number per se. You're going to be given that data on your test, which is why I'm teaching you about the bell curve, so you can draw this to help you answer the questions on the test in case you don't understand the questions that you're being asked. All right. Now the T-score, okay? The T-score for most people is typically confusing because they're like, okay, what is this? Why do I see a 50 and why do I see a 10? The luxury with the T-score is that the T-score, the mean is always going to be 50 and your standard deviation is going to always be by 10. Okay? So what you'll see here is that your T-score, your mean is at 50 and you are deviating by 10. So it's going to go up. Similarly to kind of a football field, kind of. But I'm going to leave that alone because I don't know nothing about football. So I'm not even going to confuse y'all like that. All right. So your mean, your average, mean equals average. Mean is average of your raw data. Your standard deviation is always going to be 1, 2, or 3 positive, 1, 2, or 3 negative. Your Z-score, very similar. The only difference is your mean is going to be equivalent to 0 and your standard deviation is going to be 1, 2, or 3. So think raw versus converted, I guess is the best way to remember that. But the language can be used interchangeably because your standard deviation, it will either be by 1, 2, or 3 positive or 1, 2, or 3 negative when you're talking about standard deviation and Z-scores. Okay, so let's look at the next graph. All right, so for this graph, I want to expand on the information from the previous graph, which is why I said you're going to see it different. So I think we use blue for standard deviation. All right, so on your exam, you may get asked questions around what percentage of the population scored between this and this. So I'm going to go over percentages of your graph. Whether you know the information or not, 3 numbers you are going to want to remember. The first number is going to be 68%. Let me blow this up. Yeah, your first number is going to be 68%. Your next number is going to be 95%. And then your third number, 99.7. All right, so let's get into why these 3 numbers matter and why it's going to be important on the exam. So I'm going to kind of blow this up just a little bit more so that we can see. So remember when I mentioned on the previous slide that your standard deviation is typically going to be 0, and you're either going to be +1, 2, or 3, or -1, 2, or 3, or your z-score, or your mean, and it'll just have 1, 2, or 3. So your z-score has a mean of 0, remember. And then on your true data, your mean will be whatever that middle number is, but your standard deviations is always going to be 1, 2, and 3 to the right, 1, 2, and 3 to the left. Now, percentages is what's going to be important when you think about 1, 2, or 3 to the left, or 1, 2, or 3 to the right, or a conjunction of those numbers. So 1 standard deviation to the left, or -1 standard deviation, is 34%. +1 standard deviation is 34% as well. So what that means is 34% of your raw data is going to be between 0, your mean, and 1 standard deviation, or 1 positive standard deviation. Or it means that your data, 34%, is going to be between your mean and -1 standard deviation. Okay, so the 68, where did I get that? So 34 plus 34 gives you 68%. Now, when you go back and you think about how some of the questions will be asked, you're going to get a question very similar to what percentage of your data falls between -1 standard deviation and +1 standard deviation. And you should off top understand that 1 standard deviation to the left and the right together is going to be your 68%, which is why I made sure to make note of remembering those 3 numbers. Now, if you don't remember those 3 numbers, it's also okay to just remember 34%, 14%, 2%, and 0.1%. And that's important because you can just put the numbers in here just like it is on this graph that you're looking at on the screen. So what is the 95%? So 95 is between +2 standard deviations and -2 standard deviations. So where do we get 95%? So 34 plus 34 is 68, which is going to be your data here between here and here. That's 68%. All right. But then your data between -2 standard deviation and +2 standard deviations is 14%, 14%, 34%, and 34%. So you got 68 plus 14 plus 14. 95. I know that that's not what that adds up to, but for the sake of your exam, that's kind of what you want to think. Now, the true numbers that you will see in like your statistics class is probably going to be 13.9% instead of 14%, which is why you get the 95 versus I think 96 is what you would get. So you just want to make sure that you understand what you're reading. So 68 plus 14 plus another 14 is going to give you 96. But for the sake of your test, you're going to think 68, 95, 99.7. Okay. So where is the 99.7 coming from? The 99.7 is going to be coming from -3 standard deviation and +3 standard deviation. So it's going to be here all the way to here. So everything between -3 and +3 standard deviation is where 90 9.7% of your data is going to fall. So I promise I'm going to full circle it when we get into the practice questions and how you can use this to help you answer these questions. So for the sake of what we went over, your Z-score is typically used interchangeably when you're talking to people, but they're not technically the same thing because your mean is not 0 in your normal distribution. But if you're thinking about Z-score, your mean is going to always be 0. T-score, your mean is going to be 50 with a standard deviation of 10. Now, on your traditional standard deviation or your normal standard deviation, it is going to be given to you the amount of distance between -1 and 0 or +1 and 0, or from standard deviation 1 to standard deviation 2. It is going to be given to you. But in order for you to answer the questions, you kind of got to understand the graph. All right, so I'm gonna stop rambling. Let's get into the next part. All right, so the next part is going to get into skewed distribution. So in the previous 2 slides, you saw me talk a little bit about how your mean, median, and mode with normal distribution of data is always going to be on that middle line. But here you have skewed distribution. So when you think about this, if you're trying to remember, okay, where are these numbers going? Why does this make sense? Or what this is? One thing to remember is negatively skewed, you have a tail on the left. So you'd be like, to the left, you are negative, you gotta go. Think Beyonce to the left, negatively skewed. To the left is a negative connotation if you understand what the song is telling you to do, okay? Now, positively skewed, which I don't know how this is showing up on the YouTube video, but I hope it's showing up the right way. But this is my right side, all right? So positively skewed is going to have a tail on the right side. So think I'm going in the right direction. This is a positive sign. The tail is to the right. Okay? All right. So what does that actually mean? What that means is that, again, as I mentioned, your mean is the average of your data, and it is going to tell you whether or not your data is more on a positive scale or more on a negative scale. So what that means is, if we use an example of your professors posting test grades, let's say the average test score, the passing score is a 70, but let's say on a scale of 0 to 100 of what you can score on an exam, the passing score is 85, or the average of all of the students that pass is 85. That means that your data, your mean is here. Your median, which means the middle number that people probably scored on the test, is probably going to be less than over here. And then your mean, which is your, I'm sorry, I said that backwards, y'all. The mean is not where majority of your data is because it's skewed. Your average is skewed because of how the data shows up. So if majority of your students pass at an 85%, then your data is going to be skewed because the average is 85. Now, your most scored score or your mode is probably going to be significantly higher because your average is at an 85. So that means probably majority of your data is skewed. All right. And then your mode, your median, is probably going to be in between your mode and your mean. It's most likely going to be in between your mode or mean. Now, you don't have to get into the descriptive information of what I just said. Your biggest thing is you're going to want to know you're going to want to know skewed. Positive is to the right. Negative is to the left. Negative connotation. If you want to remember, think mean, median, mode is usually how you say the words mean, median, and mode. So your mean is going to be less than your median and less than your mode. So your graph will have a left tail. It's going to be like a negative connotation. Now, still think mean, median, and mode, but write it backwards. So start at the bottom, your mean, your median, and your mode. So if you can't remember the actual accurate information as to why it's skewed, just think mean, median, mode, which is where the peak of your data is going to be. in a huge drop. So left, mean, median, mode, and then think mean, median, mode coming up in the opposite direction. Okay. I hope I didn't confuse you. So I said all that to say is we're not even talking numbers just yet. Think words and remember where they belong. So if you look at this graph, you start with mean, median, mode, and then on the opposite side, right, where it's positively skewed, same thing. It's mean, median, and mode. So when your mean is lower than your median and your mode, think that's bad. That's negative. Now, it may not be negative based on the data that you're looking at. Like if you're trying to tell somebody what the data means, but on paper and based on this graph, it's a play on words. That's all it is. So don't think, oh, it's not good, it's not bad. This data, based on what type of data you're reading, it doesn't matter. Think my mean is less than my median and my mode, and that is negative, and my tail is going to the left. If we're going more positive, my mean is still less or smaller, but my tail is where my mean is on the right side. So we're going more in a positive direction, meaning my mode starts here, median, and then mean. So it's a bell curve, mean, median, mode, just draw it out that way. Mean, median, mode, draw it out, or write it out like that so that you can see the data, or see it and say it how you need to say it if you just draw it when they give you the scratch paper on the test. Okay. I know that was very confusing. I am so sorry, y'all, but hopefully how I described it makes sense. Okay. Everybody should kind of know this. So again, we're not too much worried about this correlation coefficient word. Our biggest thing is we're thinking positive correlation. Is it going in a positive direction? And negative correlation, is it going in a negative direction? And which means that there is some sort of correlation or relationship, because that's what correlation means. There's some sort of relationship happening between the data on the X and the data on the Y, and how they I guess are related. So no correlation means that the data is all over the place and there's no relationship and we can't do anything with the data, or we can't provide a description outside of there is no correlation. Like I can't give you MX plus B. I can't give you an equation for something that has no correlation because the data is all over the place. Now, if there's a correlation, 9 times out of 10, you can pick 2 points and probably find the correlation coefficient. Sorry, y'all. These words are messing me up. So let's get into the practice questions. All right. So this is what I was talking about. So a psychology professor administers an achievement test to his class. The mean of the distribution score is 110 and the standard deviation is 22. In this distribution, a raw score of 154 will be equivalent to what Z-score? Okay. So let's get to it. So remember, let's draw the bell curve. Okay. Down here, we know our Z-score or our standard score. Remember, you're going to hear people use it interchangeably. They're not the same thing. Okay. All right. So our mean is 110. So remember how I said your raw score? We're going to put our raw score of 110. All right. And then remember I said they're going to always tell you what your standard deviation is. So my standard deviation is 22. Okay. So we got 110 plus 22. That's going to give me 132. So then we got 132 plus 22. That's going to give me 4. That's 5. 154. All right. Now we're going to do, it's going to be 88. All right. Okay. So that's what we drew. Now remember, I mentioned this is going to be your mean and standard deviation of your raw data. So remember, I mentioned that You're going to hear people use z-score and standard deviation interchangeably, which again, I'm still not sure why that happens, but let's talk about z-score. Remember what I mentioned about z-score? Your z-score, your mean is always going to be 0. So that's, we're going to put 0. Then we're going to go +1 to the right. And then we're going to go +2 to the right. And then over here, we're going to go -1 to the left. And then we're going to go -2 to the left. All right. So again, if you didn't understand what that question means, just draw a bell curve and put the numbers where you think they belong. Okay. The raw score of 154 will be equivalent to a z-score of. So remember, this is your raw data. And down here, this is your z-score. This line right here is your z-score. So your z-score is going to be +2. Okay, draw the bell curve, put the numbers where they belong, and you should be able to answer the questions with doing minimal math and without feeling confused. If you know what the z-score is, z, 0, z, 0, your mean is 0, standard deviation is 1, 2, 3 to the left, 1, 2, 3 to the right, negative. I said that backwards. Y'all know what I'm trying to say. And then with your raw data, your standard or your mean is going to be your raw mean, whatever is calculated or given to you on the exam. Typically, it is going to be given to you. You are not going to have to calculate that. Usually yourself is going to be a question very similar to this. And then your standard deviation will be given to you again. You're not going to have to do the whole mathematical equation to figure out what your standard deviation is. It's going to typically be given to you for the sake of the NCE. So that question, hopefully it made sense, and I hope I didn't confuse y'all even more. Sorry. So next question. Suppose the scores on the test have a normal distribution with x = 0 and the standard deviation is 12. What percentage, here's a percent question, what percentage of students have scores higher than 92%? And what percentage of students have scores between 54 and 68? Now, if you don't know nothing about what this question is actually asking you, all you need to remember is normal distribution and standard deviation. That's enough to tell you that you are dealing with the bell curve, okay? So let's draw it out. So we're going to draw the bell curve, okay? So x = 80, that's your mean. Okay, if you didn't know that, that's what that number is. All right, so I'm gonna blow this up as I'm explaining it. So our mean is roughly in the middle and it is 80. Our standard deviation was 12. So to the right, I'm gonna go 92. I am going to go 104. Okay. Then I'm going to go to the left. Well, actually, let me do all three. I'm going to do +3 -3. So we're going to go 104 to 112. That should give us 116. Okay. Now, it's probably farther in, but y'all, I'm blowing this up, so I'm trying to make it make sense so that when you see it, it makes sense. So your 116 probably wouldn't be that far. It'll probably be in a little bit. So will your 104, but I'm drawing, so don't take it too literal. All right. As far as the drawing. So now we're going to go negative standard deviation. So we got 80 minus 12. That's 70. That's 68. Okay. 68 minus 12. That's 58, 56. Then that's 56 minus 12. That's 46 minus 2, 44. Okay. Now, if you don't get scratch paper, you're going to have to do the math in your head. You can chunk the numbers if you need to, like I did. -10, then -2, so it's easier for you. Just because the numbers are even. All right. So remember, this is your raw score. What do we know about data? What 3 numbers did I tell you to remember? The first one is going to be, let me write it up here in this corner, 68%. I also told you 95%. And then 99.7%. Oops, sorry, y'all. All right, those are the 3 numbers you're going to want to remember or need to know. So what percentage of students have scores between 54 and 68? So what we need to know is standard deviation. Did I do that right? Okay, sorry, there's probably a typo. This should probably be 56 to 68. So let me correct that. Well, let me make sure I did the math right. But that should probably be 56. I'm sure that's a typo. 80 minus 12, that's 68, minus another 12, that's 56. Okay, yeah, that's a typo. I'm sorry, y'all. I was typing too fast when I was putting this together. That should be 56, and that should be 56. On your test, the number should be right, y'all. If y'all are following me, y'all know I make mistakes all the time because it's just me looking at this screen. Anywho, all right, so how much of your data is greater than 92? So remember, this is our mean right here. This is the middle. So we know that this is 34%. We know this is 34%. We know, remember I mentioned to use the number 14. It's probably going to be 13.9, but we're using 14 for the sake of even numbers. And then this should be 2% right here. And then this should be 2% and then 0.1 and so forth. Well, and then to 0.1. All right, so we want to know what percentage of scores is higher than 92. So if 92 is our one standard deviation over, we just want to know this section right here. This whole left section or right section, sorry. So we're going to add 14 plus 2. That is going to give us 16% plus the 0.01, so it'll probably be like 16.01, but for the sake of, or 16.1, but for the sake of your test, this is probably going to be 16%. I want to know what amount of my data is greater than 92. Okay, so we know from one standard deviation going forward, if we add the numbers that we know, we'll easily get that. Now I want to know what's 56 between 68. So 56 is here. Sorry, y'all. My drawing is a little bit off. It's 14%. Okay. So that's how you answer those questions. Again, you may not have understood that question. Draw the bell curve and put the numbers where they belong. Now, raw scores are going to give you exactly what you want, and the distribution is the same. As far as percentage wise. All right, let's get into the next question. So one thing we have not talked about is going to be our grade equivalency scores and our age equivalency scores. So for grade equivalency scores, it's exactly what it sounds like. What grade level did this person score on this test and what month? Okay. So Johnny is in the 3rd grade and was given a math assessment in which he scored a 7.2 on. Which of the following accurately describes their grade equivalent score? So hopefully this was the easiest part when you were going into statistics and like reading a patient's scores from an assessment that you gave them or the mock assessments you did on yourself. Let's actually break down this 7.2 and what that actually means. So I'm gonna use a different color again for the sake of my capacity. And giving me something different to look at. So we have 7.2. All right. So this is always going to be your grade level. And this 2 or whatever's in the 10th place is going to be your months. So if we look at the answer choices, grade equivalent, that tells us that's what we're looking for. All right, so Johnny is estimated that he scored 7.2% or higher than the test takers in his grade level. No, that doesn't even make sense. That's probably not even, no, that's percentile rank at or equal to. Johnny is estimated that he scored about the same as a 7th grader would in March of their 7th grade year. Johnny is estimated that he is below average for his grade level. He's a 3rd grader. scoring at average 3. Okay. Oh, I'm sorry. Scoring at the average of a 7th grader should be on a 7th grade math test. Johnny is estimated that he scored about the same as a 7th grader would in September of their 7th grade year. So let's look at numbers or months. When does the school year start? The school year starts in August, typically in all states across the country. So August is always going to be month 1. September is month 2. October is month 3. November is month 4. December is month 5. January month 6. February month 7. March month 8. And we're going to pause there because those are the 2 months we see. We see March and we see September. Our answer is this right here. Month 2 is September. And even if you were counting from the top of the year, March would still be wrong because, again, if you're counting from the top of the year, which is still just wrong, that's not how you do that. You start at the month of the school year. If you say March, you're probably going to be wrong because March would be month 3. Duh. So that should have given you a light bulb should have gone off. All right. Next question. A student taking the NCE learned that they scored at the 86th percentile rank of all NCE test takers. How would the student best describe their test scores? Okay, so let's go through the answer choices. 86 rank percent. Okay. All right. So the student scored less than or equal to 86% of all test takers. That's not true. If he scored, like if you do, like if I, let's draw like a bar graph. All right. So this is 0% of test takers. And this is, let's say 100% of test takers. Again, if you don't know math, just draw it out. All right. And then this is where the student scored at 86%. So what that means is he scored higher than 86% of all test takers on this test. That's what that means. So not less than or equal to. He scored 86% higher than all test takers, equal to or higher all test takers. All right. The student scored, 14% of overall test takers scored better than this student. Probably going to be our answer. Okay. The student scored an overall score of 86% on the NCE. Not true. It's not asking what did he score on the NCE. It's asking his rank on his exam score in comparison to others. So always think comparison to others when you see percentile rank. The student scored lower than most test takers. That's not true. If he ranked at 86% or higher than 86% of all test takers, he did better than 86% of the population. So what that means is only 14% of overall test takers scored higher than he did. So this is your, let me use a different color. This is 14% of other test takers. So he's at 86%. That means 14% of some test takers or of all test takers score higher than him. Okay. Now you may also see, like I mentioned it earlier, where he scored higher than 86% of all test takers. That's equal to or higher than all test takers. And when I say equal to, there may be other students that fall right on the 86 percentile rank as well. So equal to or higher than 86% of the test takers. Okay. Next question. All right. So let's go through the data. Let's do the easy stuff first. Range. We know our range is the biggest number minus the smallest number. What is the range of our scores? All right. So our smallest number is 18 and our highest number is 98. So that means our range is 80. All right. Again, they don't give you scratch paper. You're going to have to make it do what it do. They may give you digital scratch paper. You know how they have the scratch paper on the screen? I hope not. I can't remember. It's been a long time. I need to ask my associates if they gave them paper scratch paper when they took it at the test center, or if it was like embedded scratch paper on the screen, which I absolutely hate that embedded scratch paper. It sucks. Okay. Our mode, our most seen number. Okay. So I see 3 70s. And then I'm going to use a different color for our other high number or most seen number. And I see 2 for 90. So our mode is going to be 70. Okay. What is our middle number going to be? So in order to figure out your middle number, you're going to line up all your numbers and you're going to cross off left, right, left, right, left, right until you're left with one number. If you're left with 2 numbers, you add them up, you divide. All right. So I'm going to blow this up so that I can actually do the math. Okay. Or put them in order. Our smallest number is going to be 18. Our next one is going to be 19. And I'm going to cross them off as I do them so I don't get confused. And then my next number is going to be 24. All right, now let's go left to right. So we're going to go 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. So our middle number, which is our median, is also going to be 70. All right, so now we got to see what our mean is. So to figure out your mean, you're going to add all these numbers up and you're going to divide by the total number of numbers. So there's 15 students, so that should be our total. So let's add them all up. And this is what I was talking about where I said I was going to use my phone. For the NCE, you'll probably get an average of 5 numbers and not like as many numbers as you see here. But let's do the math. So we got 76 plus 24 plus 18 plus 28 plus 19 plus 70 plus 77 plus 90 plus 90 plus 57 plus 60 plus 70 plus 70 plus 86 plus 98. Okay, so I got 933. That's the number I got. And now we're going to divide that by 15. Now, I'm not about to do long division. I can do it, but I'm not going to do that for the sake of time. So we're going to do 933 divided by 15. And our mean is going to be 62.2. 62.2. So it's asking us, how is our bell curve skewed? So remember, there's this one, which is... Remember I said you're going to have a tail to the left and it is going to be negatively skewed. So let's go back up here. The tail is to the left and it's negatively skewed. So let's go back over here. And so remember we said the mean is down here. The middle is the mean. Median. Remember how I said it's going to always go mean, median, and mode? And then if we look at the table, it's mean, median, and mode. Y'all following, right? All right. So mean, median, and mode. And I'm just going to use M's for the sake of this. So our mean is 62. Our median is 70 and our mode is 70, which makes sense. So that means our bell curve is negative. Okay. Even again, if you didn't know what that meant, just draw it out like we talked about earlier, and you should have the correct answer. Now, you'll have answer choices. You wouldn't have to just answer these outright like freehand like I am, but I'm showing you. Follow me. All right. Here go another bell curve question. So I think this is probably like the last bell curve question, and the last two are pretty easy, and then we'll be done. I know it's taken me a while to get through this video, but I want to make sure I break it down and actually go into it. So let's draw a bell curve. So the normal distribution has a mean of 35 and it has a standard deviation of 5. So let's draw this out. Okay, so our mean is okay. So our mean is 35 and we have a standard deviation of 5. So that means I'm at 40 here. I'm at 45 and then I'm at 50. Y'all, I keep telling y'all my graphs ain't necessarily symmetrical like they supposed to be, but you get the drift. All right, so now I got 30, 25, and 20. All right, so remember, for our z-score, it's going to be 0, 1, 2, 3, -1, -2, -3. All right, we ain't did nothing else. We also know that between here and here, that's 64%. We know between here and here, that's 95%. And then 99.7. All right. Now, I hope I didn't confuse you by drawing it under, but I did it because the picture's so small. All right. 68% of the data is between what two numbers? All right. Y'all, I put 64. I meant 68. Y'all know what I meant. I still would have got that right. All right. So 68% of our data is between what two numbers? 30 and 40. That's our answer. Okay. 95% of the data is between what two numbers? 25 and 45. Okay. About what percent of the population data is above 40? So let's break down the numbers again. So we have, remember, 34, 14, 2, and then 0.1. We're not even going to add the 0.1, but we said more than 40. So I want to know what's here. So 14 plus 2, that's 16.1. We're going to go with just the number 16. About 16% of the data set is more than 40. Okay, that's your answer. So you'll probably get a more direct question similar to like this one, where you're going to get an actual answer choice and it's going to be looking for something specific. But if you notice, we ain't did too much math to answer these standard deviation, these normal distribution questions. You just need to know how to draw the bell curve and put the numbers where they belong. Now, also, if you notice, the ones that I've kind of recreated and recrafted questions, they're mostly z-score and your raw data standard deviation scores. You haven't seen me even go over the t-score, nor have you seen me go over the STAY-9 score, which I didn't go over that earlier. My apologies, but your STAY-9 score is standard 9, and was it on that graph? You're probably not going to see too many of those. Now, you will probably see t-score. Standard 9 or STAY-9, you're probably not going to see that on the exam because you're just probably not going to see that one specifically on the exam. But I'll go back into the image a little later. So percentile rank. We did a question like this, so we should be good to go. So the percentile rank indicates how well a student performed in comparison to the students in a specific normal group or norm group. The student scored at the 35th percentile rank of all student scores. How would the assessor describe the student score? So the assessor would say this student scored 35% better or scored better than 35% of all test takers. They scored better than 35% of all test takers. I'm sorry I wrote that backwards, but that's what that means. Or they scored 75% worse than all, or not 65% worse than all test takers. But you'll probably see it how I wrote it out the first time, which is why I'm not going to write it out like that the second time. All right, last question. So I can stop confusing y'all and messing up on my word choices. It's almost, it's past my bedtime. My alarm go off at 9:30. All right. So Dashun or Dash, whoever, who is in the 9th grade, gets an age equivalency score of 11-5. Which of the following accurately describes their... Yeah, I told you I'll be messing up. Their age equivalency score. All right. Or equivalent score. So let's go through the answer choices. So we're not looking for grade equivalency score. So I don't care how they compare to other people, grade levels. Now, although they did talk about grade, I'm looking at the age equivalency score, which is why I was given an age equivalency score. So I don't care about the grades. So what else has grade in it? Dashun is estimated that they scored about the same as an 11th grader would in May of their 11th grade year. We're going to cross that out. We're not looking for grade. We're looking at age. So you want to make sure you understand the differentiation between the two. Dashun is performing as well as an average 11-year-old and 11-year, 5-month-old child. Dashun is performing not as well as the average 11-year, 5-month-old child. Dashun is outperforming the average 11-year, 5-month-old child. So we said equivalent score. We're not comparing who's scoring better and who's scoring worse. We're looking at where should they fall. So because we're not comparing how well they're performing, we're going to throw this out and we're going to throw this out. This is our answer. Okay. I threw those two out because it says performing not as well. I didn't ask how this student was performing in comparison to an 11-year-old. I didn't. Dashun is performing as well as the average 11-year-old. That's what I'm looking at. So not as well is just not a true statement because they're equivalent to 11 years and 5 months. Then it says is outperforming the average 11-year and 5 months. Absolutely not. Because in the 9th grade, this kid is probably like 13 or 14, probably, or 12 to 14, somewhere in that age range. So they should be scoring at the 15-year-old age equivalency score or have an indication of that. So I'm sorry I said that backwards, but I hope it makes sense. So our answer is going to be A, as well, or is presenting at the same age as an 11-year, 5-month-old child. Okay, so those are all our answers or questions. All right, so we're at the end of this video. I know it's really, really long. Break it down, slow it down, rewind it, do what you need to do with it. But I hope how I break down the questions help you feel more confident about actually attacking these problems with images and with memorization of just the basic numbers or just how the graph is set up. With this image, and this image, these are going to be your best friends. So I hope this video was helpful. Again, I know it's long, so pause. Hopefully you would have paused, taken a break, or came back to it to help you dissect and take the information in. So think bell curve, think standard deviation, 1, 2, 3, 1, 2, 3, negative. Think 34, 34, or 68. Think 14, 14, or 95. Think 2, 14, 34, 34, 14, 2, 99.7. Okay, so keep that in mind and then think 0.1, 0.1. Now, again, I know that those numbers don't add up, but but for the sake of your exam, those are the numbers you're going to use. All right, well, that's it. I hope you thoroughly enjoyed the video. Again, I'm so sorry for some of like the wordplay that I did tonight or the mishaps that I made. But you got this. Rewind it, do what you need to do with it, and let's get into it.